All right, let's be honest. Have you ever looked at your data and just felt like it's not telling you the whole truth? Yeah, you're not alone. Today, we're going to dive into something called data normalization. It's basically the process that takes total data chaos and turns it into a rock-solid, secure, and scalable foundation for, well, your entire business. So let's get into it.
And that really is the heart of the problem, isn't it? You know the one I'm talking about. That single, massive table where everything gets dumped? Well, it's a minefield. It's just packed with duplicates, sneaky typos, and all these hidden risks that are guaranteed to cause you major headaches down the road. It is definitely time to fix that.
Okay, so to really see what I mean, let's invent a little company. We'll call them Hungry Now, a food delivery app. Now, business is booming, they're growing like crazy, but under the hood, their data infrastructure is a ticking time bomb, and it's all because of one single overloaded table.
And here it is, the beast itself. Just look at this thing. It's pure data chaos. Everything is just crammed together. You've got the same customer name, the same email, repeated over and over and over again for every single order. And that item underscore list underscore text column? Oh man, it's just a jumbled blob of text. This isn't just messy to look at, it is actively dangerous for the business.
So, a design like this, it's not just bad practice, it leads to a very predictable set of problems that we call data anomalies. Think of them as little gremlins in your system, specific, sneaky errors that will absolutely corrupt your data over time. Let's break down the three big ones: the update, the insert, and the delete anomalies.
Okay, first up, the update anomaly. So imagine a customer, let's call her Sarah, updates her email address. With this messy table, you'd literally have to hunt down every single order she ever made and manually change your email on each one. I mean, can you imagine? If you miss just one or you make a tiny typo, boom, suddenly your system thinks Sarah has two different emails. It's a complete mess. The fix, of course, is to have one customer's table where her email lives in exactly one spot. Simple.
Next up, we've got the insert anomaly. So what if Hungry Now wants to sign up a hot new restaurant and add them to the platform? Well, they can't. With their current setup, there's literally no place to store the restaurant's info until it gets its very first order. I mean, just think about that for a second. The way the data is structured is actually stopping the business from growing and adding new partners. That's a huge problem.
And finally, we have what I think is the scariest one, the delete anomaly. Let's say a customer places just one order from a new little mom-and-pop pizza place, and then later deletes their account. Okay, simple enough. But if you delete that one order row to comply, you might also be deleting the only record you have of that restaurant's phone number. You lose critical business information completely by accident. Poof, it's just gone.
Okay, so how do we fix this absolute nightmare? Well, there's a solution. It's a methodical, step-by-step process called normalization, and it's usually broken down into three main stages, which we call normal forms. So let's just walk through them one by one and see how we can build a system that actually works.
These are basically our three golden rules for untangling this mess. Each step builds right on top of the last one, and together, they systematically wipe out the root causes of all those scary anomalies we just talked about. You could think of it as a blueprint for creating data you can finally actually trust.
All right, the first step is called first normal form, or 1NF for short, and it's all about one super simple rule: atomicity. All that means is that every single cell in your table can only hold one single piece of information. That's it. No more comma-separated lists, no more jumbled-up text blobs. One cell, one value.
So for our friends at Hungry Now, this means we go right after that awful item list text column. We're going to break it apart. We'll create a brand new table. Let's call it order items. So now, instead of that one cell that says burger, fries, shake, each of those items gets its own separate row, all linked back to the main order. See? Simple, clean, and atomic.
Okay, on to step 2, second normal form, or 2NF. This one tackles something called partial dependencies. Now that sounds complicated, but the rule is pretty straightforward. Every column that isn't the main ID of the table has to describe the entire subject of that table, not just a little piece of it. Think of it like this. Everything in a customer table should be about the customer, not about an order they placed.
So if we look back at that original disaster table, the customer's name and their email, well, that information doesn't really describe the order, does it? It describes the customer. So to hit 2NF, we pull all the customer details out into their own customers table. We do the same for the restaurant info, creating a restaurants table. Now the orders table is much cleaner. It just holds a customer ID and a restaurant ID to link everything together.
And that brings us to the final step, third normal form, or 3NF. This one gets rid of something called transitive dependencies. Again, fancy term, simple idea. It just means that a column in a table should only depend on the table's primary key, not on some other column in the same table. No freeloading data allowed.
Now, this can be a subtle one, but it's super important for cleanup. A perfect example is the restaurant's phone number. Does the phone number describe the order? No, of course not. It describes the restaurant, so it has absolutely no business being in the orders table. It belongs in one place and one place only, the restaurant's table. It's about making sure everything is in its proper home.
All right, so after applying these three rules, 1NF, 2NF, and 3NF, what we're left with is a completely transformed database structure, what we call a schema. So let's do a little before and after. Let's look at the incredible difference between that initial mess and what we have now.
Remember this thing? The nightmare orders dump table? Just one giant chaotic file where everything was just thrown together. It was redundant, super inefficient, and basically a breeding ground for errors, a total disaster waiting to happen.
And now, would you look at that? 5 beautiful, clean, logical tables. Each one has a single, crystal clear purpose. The customer's table holds customer info. The restaurant's table holds restaurant info. And the orders table, it just acts as the switchboard connecting them. Every piece of data now has one and only one place to live. This right here is the foundation of a system you can actually rely on.
But listen, this isn't just some abstract, technical exercise to make things look tidy. This whole transformation has massive payoffs for the business. We're talking real-world benefits in security, performance, and the ability to grow in the future.
So what are those big wins? Well, by normalizing this data, we have absolutely protected sensitive information. We've cut down on wasted space and redundancy. We've made sure our data is consistent and our reports are actually accurate. And maybe most importantly, we've built a system that can scale up without falling apart.
Let's zoom in on security, because this is a huge one. All that sensitive stuff, what we call personally identifiable information, or PII, things like emails, names, addresses, it's now locked down in one single, secure customers table. This makes it so much easier to protect. You can control exactly who has access to that one table, and when a user makes a GDPR request to have their data deleted, you know exactly where to go. No more hunting through thousands of rows.
And what about performance? For the day-to-day stuff like processing orders, this clean, organized structure is perfect and efficient. But what about when you need to run big reports for the business analysts? Well, because the data is so clean, we can easily join these tables together to create what's called a star schema, a simplified view that's lightning fast for business intelligence tools. So you really get the best of both worlds, rock-solid reliability for operations and speed for analytics.
And that really is the big takeaway here. Normalization is all about creating one single source of truth, data that is trustworthy, secure, and reliable. You focus on keeping your core operational data squeaky clean, and from that powerful foundation, you can build any kind of analysis, any kind of report you could possibly need.
So, the next time you're looking at a spreadsheet or a giant database table, just ask yourself this one question, because when you build on a normalized foundation, you can finally be confident that the story your data is telling you is actually the truth.